Welcome to Lesson 12. This is Module 2, Lesson 12, Division of Integers. And the way this lesson would begin in a classroom would be for everyone as they walk into the class receive a card, and on that card they would have have an equation, um, multiplication or division fact. And what they would do is they would go around the room and they would find their partners. So what that would mean, for example, and I just did it here for you guys. The person with the 6 times 4 equals 24 card, and the 4 times 6 equals 24 card, 24 divided by 4 equals 6, 24 divided by 6 equals 4. All these people would get together because they would be one group because they are the multiplication facts, the fact family equations for this particular fact. Okay, so after that, you guys would sit down, and what you would do then is you would extend these equations here, and you notice these equations are only they only deal with whole numbers. Okay, so positive whole numbers. Okay, or positive integers. Over here, though, integers, when you use the term integer, what we are assuming is that we're going to have, both positive and negative equations. Okay. Now, this is a little bit different. This tool I'm using today, because I left my iPad at school. Therefore, it's very, very cumbersome to write numbers. So, what I'm going to do now is I'm going to go ahead and pause the presentation, and I'm going to go ahead and write down the first 2 integer facts, and I'll be back. Okay, so here's our first set of integer equations. Okay, so I'm not going to use any of these. So we're just talking multiplication right now. Okay, we're talking about multiplication. Not going to use these because these are over here when both integers are positive. Okay, this 6 times 4, 4 times 6. Now these are, we can use both of these, or we can show both of these because of the commutative property. I know many of you understand what that means, but again, changing the order of the 6 and the 4 makes no difference in multiplication. Okay, just the same idea as an addition. Okay, so but over here, when we start filling these in here, in these integer equations, we're going to use either one negative integer and a positive integer, or we're going to use, as you'll see in the following equations, we'll use 2 negative integers as well. So what I would like you to do then is take this example right here, negative 6 times 4 equals negative 24, or 4 times negative 6 equals negative 24. These two are similar, of course, different only in the order of the integers used. Okay, of course, which again is just showing the commutative property. So if you would use this example and go ahead and write as many more of this type of scenario as you can come up with. Okay, so pause here, do that, come on back. Maybe you don't understand what I'm talking about, but you will when you come back. Okay, so here's what your integer equations should look like. Okay, over here, in this case, well, in our first, the black equations up here, they had the 6's being negative and just flipped the integers around commutatively and made those 2. And then we have negative 4, so 4 as our negative integer, and again, just flipping, commuting. Okay, and then the green equations just take the both negative integers, so negative 4 and negative 6, and then again flipping them commutatively. And the first 2 scenarios we came up with negatives because we know whenever we multiply a negative and a positive, or opposite signed integers, we get a negative product. But when we multiply similar signed integers like these, as they are in both negatives, we're going to get a positive product, and the same here as well. Okay, because these are similarly signed, and you get the positive product. Okay, so now what we're going to do here in these next pages here, our next assignment, is we are going to look at transitioning from integer multiplication rules to integer division rules. Okay, so you can see what I've done here. You can't see my integer equations up here anymore because, like I said, this is a new system I'm using. So I didn't, boy, this is really painstaking. I've got to tell you to write these numbers down. So I wasn't going to do more than I needed to. But anyway, what I did is I took this, -6 times 4 equals -24, and I just related this to the division problems or the division equations that would go along with it. Okay, and you know that, division being the opposite of multiplication. Therefore, I just kind of turn this whole equation around. Okay, so now I have -24 divided by -6 equals 4, or -24 divided by 4 equals -6. Okay, these both apply and relate to this one. Over here, -4 times 6 equals -24 relates to these two equations, integer equations of division. And then we have this last multiplication problem, the two negative integers, -4 times -6 equals +24. And they relate to, that equation relates to these two division problems, okay? Where you have 24, a positive number, when it's divided by a negative number, is going to give you a negative result, okay? Okay, so here are the questions that follow these integer equation, that activity. So what we have here is we have A. So A tells us to list examples of division problems that produced a quotient that is a negative number. Now, I'm not going to go ahead and do all of those, but you can see those that produced a negative number, and examples would have been negative. We had -24, okay, and if we divided that by +4, for example, we would get a -6, okay? All right, so in this case, you have a negative divided by a positive. It's going to give you a negative. Now, you could also have a positive 24, okay, divided by a -4. It's also going to result in -6. Okay, and of course you could commute these if you wanted to, because we would have, -24 could be divided by, well, actually, it couldn't be commuted, but I mean, it could be, this could be a 6, and that could be -4. This could be -6, and that could be -4. But anyway, these two examples will yield a negative result. And again, it is either a positive divided by a negative will yield a negative. Okay, and then just the opposite, a negative divided by a positive will yield a negative as well. Okay, so you see when you have opposite signed integers, you will always result in a negative quotient, okay? A negative quotient, okay? Opposite signs, negative quotient, okay? All right, so here it says, if the quotient is a negative number, what must be true about the signs of the dividend and divisor? Well, we just said it. They're different. They're opposites, okay? They are negative and positive, okay? Well, we just said that right up there. It could either be a negative divided by a positive or a positive divided by a negative. So they are opposites. Boy, it's taking me a long time to write these opposites. I think I have something to say. Yeah, and then again, dividend, divisor, these terms. I'm not sure how familiar you are with these, but the dividend is the larger number. The divisor is a number that you are using to actually split it up, and then this is your quotient, is your is your answer. Okay, so C asks you to list your examples of division problems that produced a quotient that is a positive number. Okay, and the way we did that, of course, as we know, we had 24 divided by 6, plain and simple, equals 4. And again, this could also be 24 divided by 4 equals 6. So I'm not going to do that one as well. But we could also have negative 24 divided by negative 6. Okay. Looks good, huh? Oh boy. And that equals a positive 4 as well. Okay, and again, negative 24 divided by negative 4 would equal a positive 6. Okay, so yeah, you can see, and again, just up here, when you have opposite signs, you get a negative quotient, and now when you have similar signs, okay, you get a positive quotient. And it looks kind of familiar, doesn't it? Yeah, okay. And again, if the quotient is a positive number, what must be true about the signs of the dividend and the divisor? They are similar signs, okay? So they're similar signs. All right, they're not opposites anymore. They are similar. Similar. Okay, yeah, they are similar. Okay, and again, to reiterate, and just to write it here in our binders, rules for dividing two integers. Okay, a quotient is negative if the divisor and dividend have, I wrote it up there, opposite. I'm going to write it again. Don't ask me why. I'm sorry. This is painful for you. Okay, opposite. And as we know, we have the same situation for multiplication. Okay. We learned this in our multiplication of integers unit as well. And then a quotient is positive, where the answer is positive if the divisor and dividend have same signs or the same similar signs. Okay, there we go. We just wrote this again, wrote it once, wrote it twice. I mean, it's just good to reiterate. Okay, so here's a question I'd like you to think about, and then you can pause and maybe talk to your parent teacher about it, and then come on back. So here's the question. Is the quotient of two integers always an integer? Okay. Is the quotient of two integers always an integer? Use the workspace below to create quotients of integers. Answer the question and use examples or a counterexample to support your claim. So if you're going to use, a counterexample, if you think this is not necessarily true. If a quotient of two integers could be something other than an integer, then you can write a counterexample, okay, of that, or an example of that. Okay, so use your workspace, and this is going to be your answer. Your answer is going to be whether you believe it, yes or no. Okay. So the first one I have here in black is actually an example of when the quotient of two integers is an integer. Okay, and that's this one right here. Negative 24 divided by 6 equals negative 4. Okay, so the quotient of these two integers, negative 24 and 6, is negative 4, which is an integer. Now, another way to write this, and this is probably going to be key to you understanding the answer to this question, you could write it as a fraction. And now, this fraction is no longer an integer, as you can see. Okay, but another way to write negative 24 divided by 6 is to write negative 24 over 6, okay, because that's fractions is division, and that equals -4, okay? So this here is an example, and they're both an example, actually. I just kind of changed the way these look here, just for a reason that we'll get to in a minute. Okay, so the example in the red is actually a counterexample now of why no, the answer would be no. A quotient of two integers is not always an integer because, as you can see, if we flip these integers around, if we, if -24 and 6 change places, not only does it show you how division is not commutative, how order means something in division, whereas in multiplication it does not. So it is not commutative. You can see what happens. And the best way to do a problem like this would be to change it into a fraction. And a fraction is not an integer, but it is a rational number, okay, which integers are also rational numbers, okay? But so now we have 6 over -24, 6 divided by -24, which equals, again, I've reduced now, which equals 1 over -4, which equals very simply -4. And that's something else I'd like you just to take into, or just to look at right here, which is really, really important. You notice in this one, this example, our numerator is negative, okay? And then you'll notice here our denominator is negative. Now, it doesn't matter which one of these is negative. Now, you're going to see this in future algebra lessons where you're going to see either the numerator or the denominator depicted as negative. It makes no difference because the quotient is always going to be a negative number. Okay, always going to be a negative number. But anyway, as you can see, this counterexample here has proven that no, the quotient of two integers is not always an integer. Okay, it can be a fraction, which is not an integer, but it is a rational number. Okay, I didn't want that to happen, and that happened. I'm gonna try to get that to not happen anymore. Okay, all righty. Whew. Okay, so yeah, so here's exercise 3, and I'd like you to go ahead and take a look at exercise 3 and work it through. Let's see where we have A, there's A, B, and there's another one, C. I'm going to go ahead and scroll down after I pause, but go ahead and do those and come on back. Okay, so I figured I wouldn't do these until we came back to it, because I just wanted to see if you knew the answer before you actually worked them through. So the question here is, are the answers to the 3 quotients below the same or different? And why or why not? Okay, so if I look at these, one thing I notice, okay, if I want to predict or to know, okay, the sign that our quotient is going to have, our answer is going to have, I'm looking here and I'm seeing, oh, that's a negative divided by a positive. I know that is going to be a negative number. This is a positive divided by a negative. I know that's going to be a negative number. And this is a negative. Well, I should have negative outside of the parentheses, which is very interesting. And I'll tell you why in a minute. It's a little bit different. Maybe you haven't encountered this yet. But what that is, what is going to imply is it's going to then make whatever is in that parentheses negative at the end, the very end, because this is a good example of our Pemdas. Okay, the Pemdas rule. If you guys remember, you might not, but we'll do more of this. It's called order of operations. I know some of you know this. Some kids just love to know this and know this well, and it just excites them to no end. And I like that you know it too. But PEMDAS, if you don't know, means this is, again, it relates to order of operations. The P is for parentheses, okay, the parenthetical statements, which this is right here, this 14 divided by 7. So you actually you actually figure out what that is first, and I know that is 2, okay? Now, if I have a negative sign in front of that whole parenthetical expression, then I know this is going to be a -2. Okay, so I've given you the answer to this one here. Okay, so that's -2. But again, in terms of PEMDAS, you start out with the parenthetical parts of the equation. Then you go to exponents, and we haven't tackled those yet, but I'm sure you have in the past. We'll do a lot more of that into the future. And then multiplication and division, okay? And then there is addition, subtraction, where these are the last 2 things you do, okay? And they could be done either way. It doesn't matter if you subtract first or add first. This is not very important, okay? But anyway, well, let's get back to this one. Well, I know now that they're all negative value. I know this is actually 2. And I can see that I know that it's a larger integer divided by the smaller one. So it's going to be, 14 divided by 7 is 2, and 14 divided by 7 is still 2. Okay, so yeah, these all came out the same. I'm not sure if you guys needed to do them first, or this is probably the only one you might have had difficulty with. What does happen sometimes is that children will apply this negative sign here to both of these separately. Okay, so if they see something like that, they might say, oh, that means -14, oh boy, a mess, divided by -7. That's going to equal +2. I don't want to get into that because this is going to mess us all up. Anyway, yeah, so again, that's what that little negative sign in front of that parenthetical statement meant right there. Okay. Okay, so if you would go ahead and now before we wrap it up and get our lesson summary, I'd like to do a little fluency exercise here. We're going to do some integer division. Okay, so that's your the next page. Actually, it's the last page. Yeah, it's actually the last page in your binder. Okay, so go ahead and get a pencil ready. You can pause for now if you'd like, and then we'll get going. Okay, so go ahead and pause and get your pencil, get your paper ready, and I will hit the start button. Okay, so go ahead and get yourself ready. Okay, so here we go. I will go ahead when we get down to 15 seconds. I'll say 15, then I'll go 10 and 5 and so on. Okay, so here we go. Ready, set, go. Actually have 30 seconds left. Fifteen, 10 seconds, 5, and stop. Okay, so stop right there. Go ahead and circle the number that you got to, and let's go ahead and correct these here. So and we can go over it as we go through and what we did. So again, these are basic, some of them. Well, some of them are basic multiplication, or excuse me, basic division facts. Actually, for a long while, looks like up until maybe right here that we're looking at basic facts. Okay, so we're looking at integer answers. Okay, and I'm not thinking anyone got pretty past this first column. I'm thinking, so I'm just going to correct that column. if you don't mind. So here we go. So I'm looking at here, I'm seeing two negatives. I know right away this is going to be positive. That's a positive 8 because I know 56 divided by 7. 56 divided by 8, of course, is going to be 7 because, and again, I see that there's two negatives. Right away, they're different signs. I know it's going to be a negative result. Okay, so therefore it's negative 7. Same multiplication fact. Okay, same fact family. Still in the same fact family. Again, opposite signs. I know it's going to have to be a negative, and that's going to be negative 8. Again, fact family here. Similar signs. It's going to be a positive answer. Similar signs again. Different fact though. Different fact family. Okay, because I know 40 divided by 4 is 10. These are different signs. So it's going to be a negative 10 now. Okay. Oh, well, here we are back to 40 and 5 and different signs. So we're going to have a negative answer. Similar signs, positive answer. Similar signs, positive answer again. Different signs, negative. Different signs, negative. And it's that simple. You don't need to think too much. You see it. You've got similar signs, you've got a positive. You've got different signs, you've got a negative result. Okay. Now here's the only one that we might have been a little hard, but you see there's similar signs, it's going to be positive. And just go ahead, if it's a smaller, it's going to be a smaller dividend than your divisor. It's going to be fractional. Okay, it's going to be fractional, rational number here. And you can see similar signs make it a positive result. Here we go, we have different signs, so we're just going to make that a negative 3 over 4, okay, which is the same as negative 3/4. All right, so I'm not thinking anyone got past that, but in case you did, we have a couple more here. Similar signs, positive result. Similar signs, whoopsie daisy, positive result. Let me get rid of that. And yeah, positive result. Oh, here's a pretty, just a positives again, similar signs, positive result. Different signs, different result. Negative result. Okay, similar signs, positive result. Okay, and I don't think anybody got past that. That's for 1 minute. That would be quite a feat to have done that. Okay, let me do 20 just in case somebody got 20. Okay, different, similar signs, positive result. Okay, similar signs. This is different. I didn't say different. Similar signs, positive result. Okay, so hey, so that's it for that. We'll try to continue working on our integer division fluency and multiplication division fluency in the future. Okay, so here we are in closing. Here's our lesson summary. The rules for dividing integers are similar to the rules for multiplying integers. Okay, when the divisor is not 0. Now we haven't actually talked about that yet. I'm not sure. Maybe we'll talk about it probably in the next lesson. But yeah, a divisor cannot be 0. Okay, that is an absolute no. Okay, so I mean, while you could have this number, okay, and that equals 0, okay, you can't have something that looks like this, okay. All right, so you can't have a divisor for as 0, all right. So they are similar. Okay, so they are similar to the multiplication of integers when the divisor is not 0. The quotient is positive if the divisor and dividend have the same signs, and negative if they have opposite signs. And again, this is something we know, and again, it's something we know from our multiplication rules. Okay, let's highlight that too, because I like this little highlight thing. So the quotient of any two integers with a non-zero divisor will be a rational number. Now, why don't we say maybe integer and or rational number? Well, we don't need to say that because, okay, so all we have to do is say rational number, because now what we do is we're able to actually include fractions in here and not just integers. Okay, so the quotient of any two integers with a non-zero divisor will be a rational number. If p and q are integers, then negative p over q equals negative p over q, which equals p over negative q. And this is what I was talking about before, because if you had negative 3, this is terrible looking, negative 3 over 4, it is the same as, exactly equal to 3 over negative 4. Both of these, if we were to write them in their final form, would be just very simply negative 3/4. I do not know why this thing is so kooky and weird looking right now. But anyway, that's that. All right, so let's see. Next, you can go ahead and finish up with your exit ticket, your problem sets. Any questions, of course, always give me a call or send me an email. Next, we're going to, lesson 13 is a little bit different. We're going to convert between fractions and decimals using equivalent fractions. Okay, so we're stepping into a bit of a new realm. Okay, well, not new, but different.